So hi everyone, I'm Jeremy, and today we're going to look at some examples of interactive visualizations built with PixiJS and Jupyter widgets. But don't worry, there won't be too much of JavaScript. So you can find me on Twitter, on GitHub, and also you can have a look at my website for similar projects. But first of all, it's good to just stop for a while and look at what we have when we want to make visualizations in Python. So there is already a lot of tools, a lot of frameworks, and as you can see here on the map, they are actually clustered in different categories. So if you are in that part, so on the right side, there's more about using tools with an API close to Matplotlib. But for us, in our case, we'll be looking more at the red cluster, so that's the JavaScript cluster. So this map was presented by Jake van der Plas at PyCon 2017, and it's a good reference to know where to start when we want to make visualizations. But for us, it would be more like going really in a niche case, so using a library that is not even shown on this map for very, very specific use cases. All right, so the motivation basically is to not have what you have on the left, but what you have on the right. So really like something not like typical bar chart or typical scatter plot, but more something like interactive and moving and maybe just simple shapes such as square and circles. All right, so first of all, JupyterLab, PixiJS, and Jupyter widgets might be a lot to take in at once, but JupyterLab, if you are not using it yet, this is basically what you're seeing right now in the browser. So it's the next generation UI for Jupyter notebooks. So I really encourage you to try it out if you haven't done so yet. It adds a bunch of features. For example, the File Explorer here, you can look at your files. You can integrate it with a lot of extensions. You can even have terminal and split windows and everything. We'll look at it a bit later. All right, PixiJS, it's a powerful 2D rendering engine written in JavaScript, so it's made for the web. And it's an abstraction on top of Canvas and WebGL, so we don't have to deal with too much with all of the internals of WebGL and how it works. But instead, we can just use an API that is slightly slimmer to use as an end user. So here we have an example. This is basically a canvas with a blue background and a bunny in the middle of the screen rotating. So how do we do this? This is just as simple as creating an application, a Pixie application, loading the sprite for the bunny, putting it in the middle of the screen, and then in PixiJS, there's this notion of ticker, which is basically a function that will be called at each frame. And here, for each frame, we just rotate. We add a little bit of delta to the rotation. All right. Finally, Jupyter widgets is a framework for building interactive visualization in a browser. So it's even more than that. Actually, it's just a framework to make it easy to sync data between the kernel and the front end. So when you use a Jupyter notebook, you have a backend, which is a kernel. It can be in Python. It can be in other language, but in our case, it will be in Python. And you have a front end, which is a mix of JavaScript and HTML. And here, for the Jupyter widgets framework, the idea is you create an object on the Python side, and then there will be a counterpart object created on the other side, and then you can start modifying some attributes and the values on the Python side, and they will be automatically synced with the front end, and you can do the same the other way around. So I think it would be better to just look at an example. So here we have the IPyWidgets library, which is the official widgets library built for Python. And we're going to create an int slider that goes from 0 to 10. So we can interact with it right now. But we can also ask the notebook to show a second view for the same widget. So there we go. So we have the same view for the object we created using the int slider. And we are basically in that scenario where we have two views for the same object. And then we can access the value of that object in Python, and we can also set it, and it gets automatically synced between the backend and the front end. Right, you can create your own. There is a really good tutorial in the official documentation. And of course, there are already some libraries built on top of that and very mature. So BQplot, for example, is using D3.js on the front end to make this kind of interactive visualizations. There is IPyLeaflet for displaying maps in a browser. There is also IPyVolume to show 3D content in a browser. So it's built on top of 3.js. But for us, we're back to this little animation style. So how do we display something in a notebook like this? All right. So first of all, let's look at what we have here. So this IPyUtils package is basically just running on this machine. This is a local Python package, just standard, and it exposes this simple shape class. So let's look at the implementation of this class very quickly. So you can see that it's inheriting from this DOM widget, which comes from this IPy widget. And here we have a bunch of metadata for the widget's communication. And here we have a flag, a user-defined flag for enabling or disabling a feature. We'll see what it looks like afterwards. And here, let's put it on the side. All right. So that is on the right. That is the front-end part of this widget. So we have a model here, which also comes from the Jupyter widgets library. So we extend this base model, and then we can add our everything we want to be synced between the two parts. And then we have the view. And the view is basically where the Pixie application will be created. So we create the Pixie application there, and similar to the bunny thing we saw just before, we create the graphics, then we can call some line style, then we finally draw our rectangle in the middle, we position the shape, the center of the screen, and then we have the ticker back, and this is where we read the rotate flag, which is defined here on the Python side. And whenever we rotate, we change the rotation. So similar to the bunny example, but this is created from scratch using the IPy widget library. And when we finally make use of this, so let's close this panel and yeah. So instantiate the Python object, and we ask the notebook to display it for us. So we get our square in the middle, similar to the bunny, and then we can activate this flag, and we get it rotating, because this is what we implemented in the Pixie application. Right. So building on top of this, so the entire presentation will be just starting from this little example and try to make a bit more elaborated use cases. Building on top of this, we can just say, okay, draw me 100 shapes. In that case, it's circles. We can make sure that is actually a circle by just asking Python to give us the value for this shape attribute. But we can change it here, and it gets propagated to the front end. So let's zoom out a little bit. Yeah. And similar to what we saw before, we can just start enabling flags. We can also add another one, a wobble flag, where we get whatever user-defined behavior we want to implement. And yeah, so I hope you got the idea of the intent of this kind of visualization, so that we can start looking at something a little bit more elaborated and also maybe a bit more useful. So in our case, we will start looking at a puzzle. So this is a puzzle, a wooden puzzle, and there are 16 triangles, and the goal is to put them all in a big one. And there is one constraint is that the colors need to match. So for example, if you look at the one at the bottom right here, we have black matching with black and green matching with green. And then we have to continue adding all of the other triangles so that there is no conflict of colors, basically. So of course, you can start playing with this, like if you have the toy puzzle with you, just try to make your way and see if you can find a solution. But you can also go the other route and try to solve it programmatically. And since we are in Notebook, since we are using PixiJS, we can also make use of all of these tools and just build on top of them to draw a visualization right in the browser. Because you might want to solve this puzzle programmatically, but then without the visualization, it can be hard to know whether you actually found the solution or not. When we have this kind of really visual problems, it's much nicer to have something like a direct feedback in a browser. So let's look at what we have here. So to spare you the details of implementing a visualization for this is all encapsulated in this widget. So the widget was built following the same style as the previous example, but we can just use it right here in a browser. So what we see, we get our canvas, we get our 16 triangles aligned on the right, and then we have all of the colors, everything, and we also have additional controls. And those controls come from the IPyWidgets library. So the cool thing with the whole Jupyter widgets framework is we can reuse a lot of stuff and we can connect them together. So we will see later what happens when we click on buttons. So the idea is you can add some kind of hooks, and then whenever you click on a button, you can trigger an action on the canvas. All right. So what can we do with this widget? The idea is to also be able to visualize animations. So be able to visualize transitions between states. So like we will start playing with a toy in real life, we start placing triangles, and we will add a new one. But it would be cool if we could see those triangles moving around and see what's happening under the hood when we start solving such a problem. All right. So in our case, a state is basically just a list of 16 elements corresponding to the 16 triangles. Here we have triangle number 13. Let's zoom a little bit. Triangle number 13 with rotation 1 at the first position, and here we have another one, the number 12, with rotation 0. So rotation is encoded as an integer from 0 to 2, 0, 1, 2, to show whether we are rotating the triangle or not. All right. So now we have a model for the state, and we can see how we can use it in our little widget. So here we pass a bunch of test states. So we have here empty state, so there's nothing, and then we start placing triangle 7. We rotate it one time, we rotate it two times, then we add triangle 0, we rotate it again, and then we bring everything on the board, and we rotate everything one time to the left. And this is how it looks like. So this is time to make use of these little controls. So maybe it's time to make it slower. All right, so we have our triangle number 7 brought on the board, rotating 3 times, and then we have number 0 that we bring, rotate one time, and then we bring everything at once, and we rotate everything at once. If we don't want to do all of this manually, we just click the play button, and this thing will be looping all the time. And if we are bored, we can also speed it up so it goes faster. And then we also have extra buttons such as start and end to go from the beginning to the end and so on. All right, or use this little slider here to go a specific position in this list of states. All right, so that's our tool. That's what we have. Now we are finally ready to solve the puzzle in Python. So the idea again is to really not touch JavaScript at all and just have the interface in Python so that we can actually implement the algorithm there in the notebook and let the visualization do the job of showing us feedback. All right, so here is an interface, and you can see here this is the solve method that is not implemented and that we're going to implement. We can make use of the log method, which is basically just taking a snapshot of a current state that we can append to this big list and then visualize later. And there is also this found method, which is going to check all of the triangles, whether they have any conflict in terms of colors or not. And here is basically checking for all of them that they are actually good. So isValid might be a little bit tricky to define this one first. A little bit tricky to understand what it means. So it's taking an integer I that corresponds to the position of a triangle to check between 0 and 15 inclusive. And it's returning a Boolean which would be true if the triangle at position I doesn't have any conflict of colors, otherwise it would return false. And if we look at this example here, for triangle number 7, we see that red is matching with red, but black is not matching with white. So it's going to return false. And we can make use of this API that is defined in the widget itself so that the person consuming the widget can reason about the problem in a much easier way. All right. So first try, why not just randomly sample the whole board and see what happens. So 200 times take a random permutation of the board and then take a snapshot so that we can visualize it, check if it's found. If it's found, then we just say, OK, we stop, and we can execute this. Unfortunately, we didn't see our little print, which means that we didn't find the solution, and which is expected because just searching randomly like this doesn't bring us anywhere. So yeah, it's just a little warm-up to be able to play with this widget. So we can continue like this 200 times, but we can also spare the pain and go directly to the end. And of course, it doesn't match, but at least we have a very direct feedback. We know, oh, this is wrong, and we can move on. All right, so now we're going to look at a better implementation. So in our case, we'll be using a brute force approach, so by just recursively placing all of the triangles one by one, and then when there is one that it doesn't match anymore, we just remove it from the board. So the typical recursive problem. And here, the method for that is called place, and it's taking the position of the triangle we want to place at that time. And in a recursive approach, there is always a base case. In our case, it would be whether we have placed all the triangles or not. If they are all on the board, it means that we managed to place them all without any conflict before, so it means that we finally found a solution. Otherwise, we have to go through all of the other triangles that are left, check whether they are used or not. If they are used, we skip. If they are not used, we just mark them as used, and then we go through all of the rotation. This is where we take the snapshot to be able to visualize what's happening when we rotate the triangles. And then we finally make use of our little isValid function for that particular triangle. And if this one is saying, OK, this is valid, then we can continue and recurse one more time by checking triangle number I plus 1. All right. And if none of this works, then it's time to undo the thing and also take a snapshot there. So let's run this and run this. OK. What we get is, yeah, we found a solution and also 10,000 steps, so it's going to take a long time to look at all of this stuff. No, I'm kidding, but we won't be looking at one by one. So we can just display it again with the same widget and start going through the entire thing here. So let's slow it down a little bit, maybe a little bit more. All right, so as you can see here, we just go from in the list, we just place them one by one, and then here we're looking for white and blue. We found one, we just leave it on the board. Where we're looking for a red color, we also found one, we leave it there, and so on. And the idea is to see when we implement such a thing what happens. So you can move on and see, for example, iteration number 1,700. So it's looking good. It's looking good, but we still have 9,000 left. So it means that at some point there is some backtracking involved because one of the previous choices was wrong, and we have to go back to the beginning in some way. But we can just let it play on its own and see what happens. It's the end. Yeah. So and now in seconds we finally have our answer, and yeah, we can double check all of the single colors one by one, but that's it. That's the solution. And we don't have to just check one by we will get an array instead of numbers. It would be much harder to know whether we have found a solution or not. So that's basically it. And this example has more details if you look at this article there. So it's also using a different library, so P5JS, which is similar to PixiJS. So if you're interested in also how to create the JavaScript part of such visualizations, then you can check the code on GitHub. You can also run it on Binder without having to install anything on your laptop. But now let's go back to, let's continue with something even more elaborated. So let's talk about games a little bit and how to view states of games. All right, so the game we're going to talk about is called Perspiral, and it's developed at Wooga, where I'm currently working at, and it's a hidden object game. It's available on Android, on iOS, and also on Facebook as a WebGL game. All right, and it looks like this. So this is the core game. So it's a hidden object game. It means that you get a list of items, of objects you have to find in the scene, and the faster you find them, the more bonuses you get, the more points you get, and then you can use the points and bonuses to buy items that you can place on your island. So the main character has an island, which is actually yours, and then you can start placing buildings, decorations, and so on. You can buy cash, you can use your coins, and so on. So in our case, in this game, a player has a progression, so how far in the story the player is, but there is also a representation of this island for the player, and this is basically just a JSON file, so it's stored like that, like a bunch of metadata for all of the items. And sometimes what we get is requests from players because they left the device to their kids, and the kids, they just started to play with the game and deleted every single item, and then they ask us, can you please restore my game state as it was 2 weeks ago or so on? And we have a tool like this for customer care, and they can use it to actually check the state of a player at a given time, and then help the players to go back to where they were before. So this is a tool written in PixiJS, and is also running in a web browser. And it was authored by a colleague of mine, Benedict, also working at Wooga. And basically, I don't even know how this thing works inside, but it doesn't really matter, because here what I would like to show is how we can actually make use of the same tool, which is used here by customer care, but in a different context. And in this context would be a Jupyter Notebook. All right, so and the goal for that, I mean, why would we want to have access to such a widget? Well, once we have a player state in JSON, we can start playing with the player state itself using Python, and this is what I will show you right now. So let's look at a player state first. So this is a list of objects, of dictionaries, where we have X and Y to show the position of the item on the island, and then we also have the type of item that is at this particular position. All right, and this is our widget, and we can create a widget here, and we can set the state that we just displayed before, and we can just ask the notebook to show the widget for us. So we get our widget here, and this corresponds to the state we saw before. And since it's exactly the same tool, we can just use the exact same features, so we can zoom and hover on that and just explore a state of a player directly in a Jupyter. But then we can do more. We can start looking at what happens if I replace the state we have here by another state. So here we have another example. And you can see that the widget is going to pick up the change on the state attribute, and because this state attribute was propagated from the kernel to the front end. And then on the front end, we can pick up that change and show the new state in real time. All right, so we can also use these kind of tools here to actually modify the state in real time. So here, using the notebook. So for example, we can just say, okay, just display me half of the items on the island. So now we are going to reload the entire island, but it's half empty. And we can also use this kind of widget to just build a state from scratch and maybe do some kind of experiment, see how where people place their items on the screen and on the island. So for that, we can just say, for example, let's use position X15 and then put all of the items in a straight line. So if we execute this, we see that they are indeed coming up in a straight line. It's completely arbitrary. We can do something a bit more advanced. And if we change that, for example, not 15, but 25, then now we are using X25. All right. So that's basically the kind of visualization you can make when you start leveraging the entire JavaScript ecosystem. And that was the recap. And then in terms of applications, so as we saw, it's quite a nice tool to be able to actually see what's happening. So for example, in the case of the little puzzle, let's say you have an assignment for a student in a university or whatever, and you don't want them to bother too much with the visualization. So you just, okay, here is the widget, here is how you can see whether your solution is good or not, and now it's time to implement your algorithm. So I think this is the kind of thing we're starting to see already in this whole JavaScript cluster. If you remember the map in the beginning, where we have interactivity using existing JavaScript libraries. But I think it's really great for this kind of applications. And then now we are starting to look at actually games written in JavaScript in a browser, and in our case in Jupyter. So there are tons of applications we can do with this. Of course, there is one downside, which is that you have to build this whole visualization. So in that case, it's implemented in a mix of TypeScript and JavaScript. So you have to put the effort to actually create that visualizations. And as we saw here, it was really like for a specific use case. So, of course, it's not like as generic as this kind of BQplot libraries that we saw in the beginning. All right. So there are a bunch of references on the Jupyter widgets. A lot of very, very good work already done. You can really have a look at that. And of course, if you have any questions, right now is the right time. Or you can also ask them on Twitter, GitHub, or my website. Thank you for listening.